Get ready to geek out. Did you know that some of your favorite sci-fi gadgets are actually real? Take flip phones, for instance. They're basically just futuristic communicators from the Star Trek universe come to life. And if you've seen those cool 3D printers, guess what? They bear a striking resemblance to the replicator tech from our favorite space shows. While our modern 3D printers can't quite match the speed of their sci-fi counterparts, they're still pretty mind-blowing. But we've only just begun to scratch the surface of what's possible, and it's anyone's guess what incredible tech will become a reality in the future. Will we soon have warp drives to explore new galaxies? Maybe not exactly like Star Trek, but who knows what next-generation innovations might make interstellar travel a little more within our reach. The possibilities are endless, and that's what makes this journey of turning sci-fi into reality so exciting, and it all starts with the imagination. Get ready for the mind-blowing stuff. A team of genius scientists, led by Dr. Jim Woodward, is working on an impulse engine straight out of Star Trek. That's right, we're talking warp speed here. This cutting-edge tech could propel us to nearby star systems in a blink of an eye compared to our current space travel time. But here's the question: how does a simple toothbrush fit into this epic quest for interstellar travel? And are we finally about to make Jupiter our next-door neighbor, or will it still take centuries to get there? Buckle up and let's dive in. Buckle up, Trekkies. You're probably wondering, can we really make warp drives a reality? Can we blast off like the Enterprise and zip through space at mind-boggling speeds? The truth is that scientists have been studying the concept of warp drives for decades. But there's a catch, or rather, the speed of light. According to our current understanding of physics, nothing can go faster than that magic number 186,000 miles per second. So, what do you think? Will we ever be able to defy the laws of physics and make Starfleet-style space travel possible? Let's talk impulse power, the secret behind the Enterprise's quick getaways and stellar maneuvers within star systems. You might be surprised to learn that this trusty engine lets them hit up to a quarter of the speed of light, which is still crazy fast by our Earth standards. But here's the cool part: impulse engines aren't just sci-fi fantasy. They're based on real-life physics principles. In fact, scientists are already working on developing propulsion technologies inspired by these fictional powerhouses. So, who knows? Maybe one day we'll be using impulse-like engines to explore and travel through our own galaxy. You heard that right. It's not just Starfleet pushing the boundaries. In the real world, physicist Jim Woodward and his team are actually working on creating an impulse engine straight from the pages of our favorite sci-fi show. Can you believe it? It goes to show that science fiction can inspire some seriously cool advancements. And who knows what the future might hold when it comes to space travel? Maybe one day we'll be boldly going where no human has gone before, just like Captain Kirk and his crew. Imagine being able to travel across entire galaxies without having to endure centuries of space travel. Sound too good to be true? Well, thanks to Jim Woodward's revolutionary impulse engine, dubbed the Mega Drive, we might just make interstellar travel a reality within our lifetime. This ain't your average science experiment. After pouring his own heart and wallet into it for over 3 decades, spending around 200 grand of his hard-earned cash, Woodward's tireless efforts have finally caught the attention of NASA in 2017. Talk about perseverance paying off. Let's dive into the mind-blowing tech behind impulse engines and see if we can demystify this sci-fi wonder. So, in the Star Trek universe, the trusty impulse engine gets its power from electricity generated by a deuterium nuclear reactor. Think of it as a super-efficient powerhouse. But here's the cool part: on our planet, scientists are actually working on something similar. It's just that instead of relying on fancy space reactors, they're developing more conventional ways to harness and amplify energy, like Woodward's impulse engine. It's not exactly like flipping a switch to warp speed yet, but who knows what the future might hold. Now that we know how the Star Trek impulse engine works, let's see just what kind of power we're talking about. The electromagnets in this engine heat up plasma, and then magnetic fields guide it through a nozzle, giving the spaceship one heck of a thrust. But here's the jaw-dropping part: if an impulse engine were to explode, it would unleash an energy equivalent of nearly 98,000 megatons. That's roughly 6,200 times more powerful than the infamous Tsar Bomba, the largest nuclear bomb ever detonated on Earth. You're right, we can't even imagine creating such destructive power here on Earth, let alone in space. The Enterprise crew had a close call when they took down the Doomsday machine by triggering its impulse engine. And just think of the scale. If that device were headed straight for us, we'd need over 1,670 Tsar bombas to stop it, which is simply mind-boggling. Now that we've saved the galaxy, let's dive into some real-world tech. While Captain Kirk may have outsmarted the Doomsday machine, Woodward's Mega Drive is a far cry from Starfleet technology. It uses piezoelectric crystals instead of nuclear power. These same crystals, which can be found in your electric toothbrush at home, are key to making the Mega Drive work its magic. So there you have it, who needs warp speed when you've got tiny crystal wonders. So here's the cool part: when a specific electric frequency hits those piezoelectric crystals, they start dancing, expanding, contracting, and vibrating away. This vibration creates a one-way thrust that makes the Mega Drive accelerate. But don't get your hopes up for any intergalactic travel just yet, because it only moves a tiny bit. And if the crystals keep going back and forth without stopping, you guessed it, our little engine stays put, no space exploration in sight. You thought you had it figured out, but there's more. It turns out the crystals in the Mega Drive don't actually change their mass. They just shift it around really fast while vibrating, creating a force that propels the device forward. And here's the million-dollar question: how does this magic happen in space where there's no air resistance? Well, it seems like the laws of physics are still firmly in place, even for Mr. Scott. And that's exactly what makes this technology so fascinating. Hold on to your seats, folks. It looks like we've got a physicist from our world, Dr. Woodward, who's about to blow Mr. Scott's mind. He's working on an impulse engine called the Mega Drive, and it uses something called the Mach's principle, short for mass and inertia, are influenced by external fields. Essentially, this idea says that everything in the universe affects all matter here on Earth, even if we don't feel it. This technology might just be the key to making the impossible possible. Get ready to visualize something mind-blowing. Picture this. On a stretchy trampoline, you place a massive weight at its center, creating a sort of cosmic dip. Now, roll a ball across it. Guess what happens next? The ball starts moving in circles around that heavy central point, like a tiny planet orbiting a star. That's basically the Mach's principle at play, and Dr. Woodward thinks this could be the secret to making his impulse engine work. Let's take this idea to the next level. Just as planets cruise around massive stars, our trampoline trick helps us understand why objects move in space. But here's the catch. For that cool depression to form on our stretchy surface, you gotta give it a good squeeze beforehand. Think of it like storing up potential energy, much like electricity building up before a spark flies. Dr. Jim Woodward and his team believe that matter in the universe is actually what gives space-time its tension, or charge, which then shapes how objects behave within it. So, just like our trampoline was packed with energy before we added a heavy object, space-time is loaded up with the universe's gravitational potential ore. It's basically the cosmic version of that stored energy. Now, here's where things get really cool. Dr. Woodward's impulse engine could potentially tap into this hidden energy to make some remarkable changes happen. Imagine if it could actually alter the mass of those special crystals inside, and voila, the device would start moving on its own. You know who might find that fascinating? Captain Jean-Luc Picard. No, wait, I mean Mr. Spock. Live long and prosper to wild ideas. The thing is, Mach's principle doesn't have any lab tests to back it up. We're talking no actual data or math to explain how it works. This has scientists splitting into two teams. One thinks developing the Mega Drive is just not going to happen because of this lack of proof, while others are totally on board with the idea. Kinda like if Captain Jean-Luc Picard from Star Trek had his own physics rule. They're willing to boldly go where no one else will. You know that old saying, right? Impossible is just until someone says why not. And that's exactly what happened here. Jim Woodward and Hyle Fern pushed past what we thought was possible. Their impulse engine prototype actually works, producing a whopping 100 micronewtons of thrust. Now, the big question: could this teeny bit of power really push a spaceship to a quarter of light speed? Let's dive in and BIGXPLAINR some numbers. Can it get our spacecraft flying faster than 60 million km? Let's put that tiny 100 micronewton force into perspective. Wow, it's roughly what you'd need to blow out 3 birthday candles, not 5 or 6. But here's where things get really interesting. There was an even smaller impulse engine prototype before this one, producing as little as just only micronewton of thrust. Now, this breakthrough may seem small, but trust us, the science community is beaming with excitement and we're not Vulcan enough to play it cool about it. So what's really got everyone abuzz? NASA took one look at these findings and decided to get their own team involved. They commissioned an independent study to dig deeper into this mini-thrust phenomenon. One member of the commission, aerospace engineer Michael McDonald, is taking a measured approach, giving it some serious scrutiny. He puts the odds of this being more than just a fluke from 1 in 10 all the way up to 1 in 10 million. Now that we've got proof this mini-thrust could be real, it's time to think big. Or rather, space big. Imagine these findings paving the way for actual space tests. Who knows, maybe one day it'll be a vital part of our journey to explore beyond our galaxy. But hold up, Captain Kirk isn't the only one with a fleet of advanced engines in his universe. Let's see what other mind-blowing propulsion systems Star Trek has up its sleeve. Let's talk about the big leagues, the warp drive. This game-changing tech lets spaceships reach incredible speeds, making those long-distance galactic explorations a whole lot faster. It's like turbocharging your spaceship to 11. As Captain Pike would say, maximum warp. Punch it. But what if I told you that scientists are actually working on a real-life version of this concept? The possibilities for space travel just got a whole lot more exciting. You're getting ready to break free from Einstein's speed limit. Warp drive might sound like science fiction, but buckle up because it's not as far-fetched as you think. In Star Trek, vessels like the USS Enterprise and Enterprise D could blast off at mind-bending speeds. We're talking warp 0.5 to warp 9.8, making intergalactic travel a reality in no time. The catch, it defies our current understanding of physics, where nothing can exceed light speed. So, how do they pull this off? Well, the idea behind warp drive involves manipulating space-time itself, creating a bubble that moves at faster than light speeds while keeping the ship inside safe and sound. It's like being in an invisible slipstream, leaving the rest of the universe in the dust. So, let's dive into what makes this mind-bending technology tick. Warp drives don't speed up your spaceship. Instead, they bend space-time around it. Imagine a bubble that pushes space in front of the ship, making it shorter, and pulls it back behind the vessel, stretching it out. This bubble effect allows for super-fast travel without breaking the cosmic speed limit. But how do we generate this warp power? In Star Trek's universe, advanced civilizations like the United Federation of Planets harness the immense energy from matter-antimatter annihilation reactors. This reaction unleashes a fiery mix called electroplasma, which powers the warp drive and makes faster than light travel possible. Now, let's talk about turning this electroplasma into the actual magic, the warp field. This energy is channeled into plasma injectors, which generate a specialized field around the spaceship, essentially warping space-time. But here's the thing, can we build something like this in our universe? Well, scientists haven't ruled out its possibility yet, leaving a tiny opening for hopeful engineers and theorists. So, it seems we've got some nitty-gritty science on our hands, and no, I'm not adding any hidden sarcasm. The universe's expansion, driven by the elusive dark energy, a fascinating concept. So, I ask you, what if we could harness this cosmic force to create our very own warp drive? Think about it, it's not as far-fetched as you'd imagine. All we need is a team of genius scientists, armed with some out-of-the-box thinking and an unrelenting passion for the impossible, the kind that comes from being huge fans of Star Trek, or just a bit mad. Now, let's turn theory into reality. Securing a NASA grant and putting in some serious elbow grease could make our warp drive vision a tangible goal. But before we officially declare our game-changing discovery, let's see what Woodward's Mega Drive can really do for us. With the impulse engine, reaching light speed is off-limits, so we need to aim for stars that are close enough to be considered next-door neighbors of Earth. Our sights are set on Alpha Centauri, the star system that's just a stone's throw away in cosmic terms. Imagine being just 4.37 light-years away from home. That's how close we are to our nearest neighbor, Alpha Centauri. Proxima b, an exoplanet orbiting in the habitable zone of our nearest star system, has got us wondering, could this be where life beyond Earth awaits? Now, let's put on Woodward's Mega Drive and see what happens. If we can blast off at a quarter of light speed, our Alpha Centauri-bound journey would take about 17.5 years. A long road trip, but still faster than the original light speed limit. The sun's brightest rival, Sirius, is calling our name. Are you ready to trade the familiar Alpha Centauri for this stunning star system? Time to buckle up. Even at a quarter of light speed, that Alpha Centauri trip still has us traveling in style, but be prepared for over 4 long years of interstellar cruising. Now let's set our sights on Ross 12080b, where scientists think life might just call home. This hidden gem boasts a planet with ideal conditions to foster life, making it the ultimate destination for any spacefaring biologist. Fasten those seatbelts, because we're about to embark on an even longer adventure, nearly 45 years of cosmic travel time. What's your top pick for a stellar destination? Drop it in the comments below, and let's get this intergalactic conversation started. And as Spock would say,